Dinosaurs were fearsome creatures. Some had thick scales, sharp teeth, and in many cases, lightning-fast reflexes. One thing they didn't have, a Planetary Defense Office. When an asteroid targeted Earth 65 million years ago, it took those masters of Earth by complete surprise. While we know of no large object that is on a collision course with Earth in the next 100 years, descendants of survivors from that catastrophic impact are determined not to make the same mistake. In 2016, human astronomers now routinely scan the heavens for signs of potentially hazardous objects. When NASA-funded survey projects have found 98% of the known catalog of almost 15,000 near-Earth objects. Asteroids and comets whose orbits periodically bring them within 30 million miles of Earth's orbit. They'll do if a dangerous asteroid is discovered. How will we know if and when it will impact? Is it possible to deflect or destroy it before it reaches Earth? All of this work from Discover's office was established at NASA. The example illustrates how all this works. Propulsion Laboratory describes what happened. The object was first detected by the NASA-funded Catalina Sky Survey near Tucson, Arizona on October 3, 2015, and tagged as detection WT1190F. Within a couple of days, astronomers suspected it was probably an artificial object. It was faint and small, with its motion visibly altered by the gentle pressure of sunlight, a bit like a solar sail or perhaps a hollow rocket body. As tracking data accumulated from multiple observers, astronomers realized that they would get a closer look. This would be a real-world case to exercise the team's skills. Orbit calculations by JPL analysts pinpointed the impact time and site. WT1190F would burn into the atmosphere off the coast of Sri Lanka. For instance, they recorded the return of NASA's Stardust Sample Return Capsule with its cargo of cometary dust. They've also observed a number of defunct spacecraft re-entries and a few natural meteor events. Support E1190F produced a magnificent fireball in broad daylight. Jeniskins says the spectra of one large fragment contained bands of titanium oxide and a line of hydrogen, so the object could have been a titanium-walled vessel containing residual fuel. Chodas, who had been attempting to reconstruct WT1190F's past orbital motion, says, "My educated guess is that it was Lunar Prospector's translunar injection module, which had a titanium case, although we may never know for sure." One thing is certain. Astronomers supported by NASA found it, tracked it, and predicted where it would hit with pinpoint accuracy.